For 4B, where we're looking at backtracking. Lesson 4A, we looked at recursion. So here, we're going to understand what backtracking is. I'm going to be using the end queen um, problem to show how backtracking works. So backtracking is an algorithm technique used to solve problems by exploring all potential solutions and abandoning those that do not satisfy the problem's constraint. So we need to understand this, right? We need to understand this. So looking at the end queen problem, the end queen is a classic problem in computer science or in computing, in computing and mathematics. Now the task is to place end queen on an n times n chessboard so that no two queens attack each other. Now there are rules to solve the end queen problem, and there are four rules, which the first one is no two queen can be in the same row, no two queen can be in the same column, not no two queen can be in the same left diagonal, and also no two queen can be in the same right diagonal. Now let's look at how the n queen works. N queen algorithm, right? So now let's assume that we have 4 by 4 chessboard, which is now this zero represent that there is no queen, right? So here I have four lists here. I have four lists here, and each of the lists have four lists, and each of the lists contains items, right? Let me let me leave it like this. And each of the lists contain items which are zeros, which represent that there's no queen. So one will represent that there's a queen, right? So here this is a two-dimensional list, right? This is a two-dimensional list, and this is 4 by 4 chessboard. 4 by 4 chessboard where we have four rows, one, two, three, four, and four columns, one, two, three, four, right? So in computer, the way this works is computer starts with this is row one, row zero starts from row zero down to this is row one, and this is row two, and this is row three, right? Now the same thing applies to column. This is column zero, this is column one, this is column two, and this is column three. Now before we start, there's reading the algorithm, right, in 2 by 2 chessboard, right? So imagine that this. Let me remove this. Let me remove this. Let me remove this. Let me remove this. Since we understood how the rows start to count, right? How the rows start to count. So let's say we have the board as a variable. Right? We have the board as a variable. Now this board here holds all these lists. So this board holds all these lists here. So this is comma, comma, right? So this board, comma. So this board hold all these lists. So what if I want to get, this is a variable called n, I want to get the length of the board. I want to get the length of the board. Now to get the length of the board, remember that if it's just one list, right? To get the length, if it's just one list, to get the length is one, two. You count the items inside the list, which is one, two, three, four, which is this. But now we have multiple lists here, which each of the lists contain rows. Each of the lists contain an item. So if you want to get the length of this board now, right, in that is two dimension, right? This board is a two-dimension board because it doesn't have just one list, it have multiple lists in it, and it's 4 by 4. You can see it says 4 by 4. So it means that it's two-dimensional. So if I want to get the length of this, I will count one, two, three, four. I'll count the rows, which gives you what? 4. Which means the length of this board is 4 because of the 4 rows, one, two, three, four, right? So what if I want to get the value located. Now, when I say board 2, 3, now what this means is I want to get the value, I want to fetch out the value located in row 2, because this first one is a row, and this second value within the square bracket is the column. So what this means is I want to fetch out the value located in row 2, column 3. So row 2 is 1, 0, 1, 2. So this is row 2. Now column 3 is 0, 1, 2, 3. So to get the value, this is the value to fetch out, right? This is the value to fetch out, so this is 0. So this is how two-dimension works, right? So let's go straight to our n queen problem, right? So let's solve this before we write the algorithm. Now remember the four rules. Now the four rules says that no two queens can be in the same row, no two queens can be in the same column, and no two queens can be on the same diagonal. Now, as a human, I can easily place the queens anyhow, right? I can easily place the queens like this. One, then I will check here. No two queens should be in the same row. Then I will check here. I can't place it here. I can't place it here, but I can place it here, right? Then I will check here. I can't place it 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 here. So as a human, I can just do this. But how will now we want to solve this? I want to show you guys how computer solves this, right? And after that, we're going to write the algorithm, right? We're going to write the algorithm so that you can understand every step of how the computer solves the n-queen problem. So let's start. So the first rule states that no two queens should be in the same row, right? You can see in this row here, we'll start with row 0, right? So in row 0 here, there is no queen, right? So no two queens should be in the same column. In column 0, there is no queen. Now, no two queens should be in the same diagonal. So you can see that row 0, column 0 here, I say there's no queen, and you check the other diagonal, right? There's no diagonal here, but here there's no queen, right? So I'll place my first queen here because it has passed all the rules. Now the second row, then I will come to row 1 now. So I'll come to row 1. This is row 1. We have, we have placed our queen in row 0, so this is row 1. So if I want to place my queen here, I can't do that because these are in the two queens are in the same column, so it won't work. So if I want to place my queen here, so these are in the same diagonal, it won't work. If I want to place my queen here, yes, it will work because just one queen in this one row. Diagonally, only one queen. You can see left and right diagonal, only one queen. But in the column, there's only one queen, so it has passed. So I'll move to row 3. Row 2, sorry. Now, if I place my queen here, there are two queens in the same column, so it won't pass. So I'll move on to the next column. If I place my queen here, now there's a queen here going down through the right diagonal, right? Going down from bottom to the right diagonal, from bottom up to the right. There's a queen there, so it won't work. So if I place my queen here, they're in the same column, it won't work. So if I place my queen here, moving down up to the left diagonal, it won't work. So what I will do now is what we call backtracking. I will now backtrack to the previous one, to the previous queen, right? Now the previous queen is in row 1, column 3, or 1, column 2. So I will move it and then move it to the next place here. Now it still meets all the rules because there's no queen. So I will come down again. So I will come down again to row 2, right? So row 2, if I place my queen here, it it won't work because there's a queen in the same column. So if I place my queen here, yes, there's no queen in the same column, there's no queen in the same row, there's no queen in the same from up down to the right diagonal, and from bottom to the right, and from bottom to the left, there's no queen. Diagonally, there's no queen. So it works. So I move down to row 3. So last row, if I place my queen here, it won't work because from the bottom down to the right diagonal, there's a queen. So if I place my queen here, it won't work because they're in the same column. Then if I place my queen here, sorry, if I place my queen here, from bottom to the left, take it down from bottom down to the left, it won't work because there's already a queen here. Then if I place my queen here, it won't work because they're in the same column, right? So what I'll do is I will backtrack again to the next one, right? I'll backtrack again to the next one, and you can see that the next one, the next queen is in row 2, column 1, right? Row 2, column 1. So it will move to the next place here to move the queen to the next. Now we can't move it here because taking from bottom to the right diagonal, there's the queen, right? So I'll move it here. Now you can't stay here because they are in the same column. Then I will backtrack again, right? I'll backtrack to this. So this queen is in row. This queen is in row 1, column 3, right? So since this will last and it will backtrack again to the next one. So this since we it backtracks to the beginning. So this beginning now, this queen moves to the next column, moves down to the next column. So it comes back to the row 1 again. So if I place my queen here, you can see that they're clashing diagonally, right? Taking from bottom down to the right. So if I place my queen here, they are in the same column. If I place my queen here, the same diagonal. If I place my queen here, then it worked. I move down to the next row. If I place my queen here, yeah, it worked. I move down to the next row. If I place my queen here, they're in the same column. If I place my queen here, they're in the same diagonal. If I place my queen here, then it worked. So finally, I've placed my 4 queens in the 4x4 chessboard, right? So if you can do this, you can do for 8x8. You can do, right? You can do for 8x8 chessboard. But remember that the 2x2 will not actually work because 2x2 there's no solution for 2x2, right? 2x2 you can actually place your queen in the way that they will actually not clash. So it's from 4x4, 8x8, and so on and so forth, right? So now let's try this algorithm. How can we pass this instruction to the computer so the computer can easily understand how to solve this problem? Although it's not that easy, but please watch this video carefully so that you can be able to understand the algorithm. Now let me put this to be smaller because the algorithm is not that the algorithm is long, so we'll be using 2 PowerPoint slides for the algorithm where we'll maintain how we walk this through, right? So I'll make it 14. Okay, 14 is very small. So let's make it okay, let's make it 18. Let me use Georgia. Okay, I have my function, right? So the first rule is to check if the row is safe to place a queen. Check safe row. Now, to check if the row is safe to place a queen, right? So let me take it back to 0. Let me take it back to 0. Let me take it back to 0. So the first way is to check if the row is safe to place a queen. So I have my parameter, which within the parentheses there's a variable called board, and there's also a variable called row. So at the end, I will return the sum of, I will explain this, sum of the board square bracket row equal to 1. Now what this means is I want to check if the row is safe for placing a queen. Remember the rule says that no 2 queens should be in the same row. That is what I'm reading here. I want to make sure no 2 queens should be in the same row because the 1 is represents our queen here, right? The 1 represents our queen. Now, looking at this, right? So assuming that if you are calling, assuming I want to call this function where I will have my check safe row. So I will have my board and have my row. So let me make the smaller side to be in a straight line, right? So here, our board, this is our board, and I want to check row 0 if I want to check row equal to 0, right? Which is this row. Let me use small letter. I want to check if this row is okay for place. It's okay, right? If this row 0 is okay. So this is our board, right? So this is our board. These are board. We have passed the arguments here in this function. So assuming that want to check, use this function to check if this algorithm works. So let's check. Now what the algorithm does is, what this algorithm does is it checks for, remember the sum. This sum is board of row. So what it means that this is the board and this is the row. It means board row 0, right? What it means that I want to fetch the value located in row 0. Now these are the values. This is row 0, this is row 1, this is row 2, this is row 3. So these are all the values located in row 0, and I want to sum all of them. Now summing them will be 0 based on this row here, sum board row. So summing them will be 0 plus 0 plus 0 plus 0. Are they equal to 1? No, they are not equal to 1, right? So they are not equal to 1. So this is actually, right? So return sum board equal to 1. So since this is not equal to 1, right? So this algorithm here will return what? False, because they're not equal to 1. So assuming that there's a 1 here, right? So 0 plus 0 plus 1 plus 0, this will be equal to 1, which becomes what? True, which means that there's already a queen in this row, right? So with this algorithm, I can't place another queen in this row again, because even if you place another queen here, it's 2, which it has gone out of the row. So it will not allow you to place any queen in this row anymore, right? So that is what the algorithm means. The algorithm is to ensure that only one queen is placed in one row, right? So, but if there is no queen here, right, then it will show that how there is no queen. Let's say it will return false that there is no queen, and then you can then decide to place a queen here if it still meets all the other rules. So this is the first rule. So let's look at the second rule. Let's look at the second rule. So the second rule here is to check safe column, to check the column if they are safe, right? So check if they are safe for placing a queen. So we have our board and we have our column, right? So I will look for I down to the length of the board. I will explain this. I down to the length of the board. So if the board I, which is the row, then the column is equal to 1, right? So I return false, right? Then if it's not false, return true. Now let me explain this. Let me explain this one here. So let's assume that I want to check. So this is the board. So let's assume I will call this function check. I call this function check safe column, right? And this is our board. We're passing the argument to this function here, which this is our board, which is 4 by 4 board. We paste it here. Then our column is, let's assume that we want to check for column 2. I want to check for column 2, right? So how does it work? This is how it works. Now for I down to the length of the board. So the length of the board is 1, 2, 3, 4. The length of the board is 4. So I will look 4 times, which is I equal to 0, I equal to 1, I equal to 2, and I is equal to 3, which is 4 times. So when I is equal to 0, then the board row 0 column row 0 column 2. So row 0 column 2 is, this is row 0, right? Column 2 0 1 2 is actually 0, right? It's actually 0. So this is true. It's not false. But remember this rule here. Say if board I column is equal to 1, return false. But here, when I is equal to 0, board 0 column 2, which is the argument we passed here as a column, is equal to 0. If you check, it's actually equal to 0. So this is true. It's not returning false. So the next one here, when I equal to 1, our board 1 column 2 will be equals to, so it means row 1, this is row 1, so column 2 is 0 1 2 is still 0, right? So this is actually true. So when I is equal to 2, check board, which is 2, row go to column 2. Now row 2 column 2 is 0 1 2, this is row 2. Now column 2 is 0 1 2, which is 0, right? It's fetching the value 0, which is actually true. Now it checks for I equal to 3. So when I equal to 3, the board will be row 3 column 2, which is actually, so row 3, this is row 3 column 2 0 1 2, it's still 2 0, which is true. So it means that if you are using this to check for column, right, it will return true because all the values in column 2, right, all the values in column 2, right, for each of the row is 0. So it's returning true. So that means it shows that it's actually safe to place a queen in this particular column, right? It's actually safe to place a queen in this particular column, right? So that is what it means. So we have written two rules. So now let's look at the third rule. Now the third rule is to check for left diagonal. So if I have my function here, now check safe left. That I will use check safe left. So I'll have my parameter, which is a board. I'll have a row. I also have a column, right? So let's run this. So what I will do now is I will have a variable called, okay, no need to have a variable. So since we have the bold, it is a row and a column. So I will loop through for okay, let me use the while loop. So why the row, right? Why the row is greater than equal to 0 and the column is greater than equal to 0, right? So what happens is now if bold row column, right, is equal to 1. So what happens is return false. So return false, right? So once you return false, what it does is it will decrement the row minus equal to 1. Then it will also decrement the column minus equal to 1, right? It will decrement the row, will also decrement the column. Then if then return true. So now let's explain this one here. Let's explain how this one works. Let me take it down so it will be bigger. Let's explain how this one works. So now let's assume that I call this function here. I call the check safe left, right? So this is our board, right? This is our board. This represents our board, which is 4 by 4, right? So our row, let's assume that our row is row 3, then our column is column 3. So we want to find out if row 3 column 3 is safe for placing our queen. If row 3, this is row 3, 0 1 2 3, right? Then column 3 0 1 2 3. So this is the value we want to try to get. So if it's safe for placing our queen. So this we are looping through because even if we check that this is 0, we have to check in the left diagonal, right, to confirm if all the diagonals are also 0, because if any diagonal is 1, it's not safe, it will return false, right? So that's why we give computer this instruction. Now let's see how this instruction works. Now this is our board, right? This is the board. Now the row here is 3 and the column here is still 3, right? So now why 3 is greater than equal to 0, which this rule stands because 3 is greater than equal to 0, and column is 3 also. So column is greater than equal to 0, which this rule stands, right? So this rule stands. Now, what happens? So if board column 3, row 3, column 3, if row 3, column 3 is equal to 1, so let's check. It's 0, 1, 2, 3. So row 3, column 3, right? So what it does is, because this is a while loop, right? So it checks when row is 3, so it means that the board row 3 column 3. So row 3 column 3 here is 0, which means is what is true, right? So it's not returning false because row 3 column 3 is equal to 0, so it's not equal to 1, right? So this is actually true. Now we decrement row and decrement column. So the next iteration becomes Next iteration becomes 3 minus 1 is 2, then 3 minus 1 also, for we decrement for column also 3 minus 1 is 2. So we want to check for row 2, column 2, right? Because of this, so we'll be decrementing it until we meet this while, until this condition is not met. And that's why we're using the while loop. So let's check for row 2, column 2. Now this row 2, 0, 1, 2, this row 2, column 2, 0, 1, 2. So this actually is row 2, which is true, right? So it goes again and decrement row and decrement row, which is 2 minus 1, which is 1, and 2 minus 1, which is 1, right? You can see we have checked this. You can see diagonally we have checked this. So now we want to check the next one, which is row 1, column 1. So this is row 1, this is column 1. You can see how we're checking from the bottom down to the left hand side, right? So that's why we're checking from the left. Now, this is actually 0, 2, which is true, right? So it goes again, which becomes 1 minus 1 becomes what? 0. And 1 minus 1 what becomes what? 0. Right? So we want to check row 0, column 0. So this is row 0 and this is column 0. So which is actually true, right? So it comes again to the while loop, right? Remember the row now is now 0 and the column is now 0. So now 0, which is true, right? Which we have done this. So now it goes down to the next one, which is the board will be, now board is 0 minus 1 is minus 1, right? Now we haven't get the value yet. Let's see. I want to show you guys how the iteration will stop. Then 0 minus 1 is minus 1. Now it comes to this, it checks, right? Now, y row, which is minus 1, y row with minus 1 is greater than equal to 0. Is minus 1 greater than equal to 0? No, this is false. So definitely it will go down through this iteration. So the iteration stops and when the row is 0 and the column is 0 because it's in decrementing, and when this row is not met, the iteration will stop. That is how the while loop works, right? That is how the while loop works. But the for loop works it count it to a number of iteration based on the length and then start doing it until it gets to the last. But this one here, how the while loop works is it has a rule, right? The while loop has a rule in the first place. So when it's met, it will stop the iteration, right? But when it's not met, it continues doing the iteration until when this while condition is met. So there you can see that diagonally, right? Diagonally, for check safe left of the board of row 3, column 3, you can see that it's actually safe to place a queen here, right? It's actually safe to place a queen here because diagonally no queen is being found, right? Taking it from bottom and to the left, right? So this algorithm is actually correct. So now let's do for the last one, which is the right. Oh, it's very small. So what do we do? Let me write the right here. So what I will do here is, let me see. Okay, let me write the right here. Let me see. Write this one. So I have my function check save right. So there I have my board row a column. So while the row is greater than or equal to 0 and the column is less than the length of our board, right? So if the board, which is a row, column is equal to 1, so this will return false. Then decrement the row because we're trying to get from the bottom down to the right. So then we'll increment the column, right? So at the end, we return true, right? So how this works is, so let's do how this works is this. So we build this black so that it will go, right? So now how this works is this. So now if we have the check safe right, right? Check safe, and this is our board. Let's use row 3. Let's use row 3, column 0 to check it so that you see how this works, right? So we want to start from the bottom. Okay, now checking this, if you check this, it said the rule states that where row is greater than zero, and the row here is actually three, right? The row is three, right? The row is three, 0, 1, 2, 3, which is this, and column zero. This is column zero, which is zero. So in the first row, which we have board row three, column 0 is equal to, now row 3 column 0 is equal to 0, which this is true, right? So it will decrement the row, which by decrementing the row, it becomes board. So 3 minus 1 is 2. Then it will increment the column, which is what? 0 plus 1 is 1. Now you can see how it's going up, right? You can see how it's going up. So it now be row 2, column 1. You can see how it takes it from the bottom down to the right hand side. So it's taking this, and this actually is zero, which is also true. Then if we do it again, where we have board, so 2 minus 1 is 1, then 1 plus 1 is 2, which is row 1, column 2. So row 1 and column 2 is also 0, which equal to 0, which is true. Now the last one is board. 1 minus 1 is 0, then 2 plus 1 is 3, right? 2 plus 1 is 3. Now equals to row 0 column 3 is say 0, which is true. Now let's assume then it goes again, right? This is how it stops the loop. It goes again and do this. So this is 0 minus 1 is minus 1, right? And this 3 plus this is actually 4. Plus 1 is 4. Now look. Now let's check. This is minus 1, right? So y minus 1 is greater than or equal to 0. So this is actually false. But then this column is 4, right? So why 4 is less than? So 4 is not less than, the length of the board is still 4. So 4 is not less than 4. So it means that the iteration will stop in where row is 0 and the column is 3. So this is where it stops. So it will return true. It means that it is safe to place a queen in the right diagonal. So we have completed the 4 rules, right? We have completed the 4 rules for the equal problem. Now, I will call this a write a function here, right? Continuation. So n queen algorithm continues. So let me make this smaller because we're not done yet. I'm not sure you guys how the backtracking works, right? So I'll write a function. Let me make this smaller, let me make it 18. 18. So I'll write a function here. So I'll write a function which is a safe. So I'll call all the rows inside it in safe here. So I'll pass my board, then the row and the column as the parameter within the parentheses here. So I'll call them. So the first one is to check row, copy, as check safe row. So I will have if not check safe row, if not check safe row, which is the board and the row, right? If not check safe row, return false. Right? So it means that if this is not actually true, right, return false, right? If it's not true, return false. So the next one is if not check safe column, which is the argument is the board and the column, also return false. Then the third row is if not check safe left, which will have the board, the row, and the column, return false. Then the last row is if not check safe right. I have the board, I have the row, we have the column, return false. Then if all these are met, right? If it's safe to place a queen, they return true. Okay, that is all these. If it checks all these, right, and it's safe to place a queen, they return true. Right? So now we have completed this, right? So now the next one is to write a function to solve the n queen problem. Well, this way I'll be explaining the backtracking. So function to solve the n queen, which will have the board, will have our row. So I'll make this 18. Alright. So now let's start. Remember that here we're going to be combining recursion and backtracking. And recursion, there's always a base case, right? So if there's no base case, this algorithm will loop infinitely, right, without actually having a solution. So we need to have a base case. First thing I have is a variable called n, which takes the length of our board. And in this case, the length of our board here is 0, 1, this 1, 2, 3, 4, which is 4, right? So we need to have a base case here. So we need to have, so if our row is equal to the length of n, so return true. So this is the base case. So when the row value get up to the length of n, so it will return true and to stop the recursion, right? So now for column down to the length, I will explain this. From column down to the length of the board, for column down to the length of the board, which means that here for column down to the length of the board, which means that here we have about 4, which is the length of the board is 4, right? So it means that column is equal to 0, and column equals to 1, column is equal to 2, column is equal to 3. That is 4 times, right? That is how the column will look 4 times. For column down to the length of this. So if I'll call this if safe because this if safe contains the for rules, alright? So if it's safe, like if it's safe for placing a queen in the board, row, and the column, right? So if it's safe, then place the queen in that particular, place the queen, which is board row, column, place the queen, which the queen, one represent the queen. So place it in that particular row and that particular column. So once it's done, so instead of writing if condition, if condition, if condition for each of them, right? So all I just need to do is to call the recursion, right? Is to call the function in itself to be able to perform each and every one of the steps, right? Until this base case is met. So that is where the recursion comes in, which I will call it, which is solve n queen, right? So this is the board and row, which will be incrementing. I will explain this. So for every once we have placed the queen, also substitute place the queen in a row, it will increment, it will go down to the next two. That's why we have row plus one, which assuming that we're starting from row 0 and we have placed a queen in row 0. So with this recursion, it performs the step again from beginning and increment row, which row becomes 1, which is row 1. We'll now try to see if we can place a queen in row 1. So once this is successful, right? Once this is successful to place a queen in row 1, it returns what true. But if it's not successful, right, then we backtrack. So backtrack, we have the board, we have the row, we have the column, and then we remove the queen from that particular row, right, which is 0. Remove the queen from that particular row and that particular column, and then we'll backtrack. So this automatically will be like going back, which is row minus 1 because it's false. That's how the recursion works, right? So if everything is okay, it will return what? It will return true. So you can see that we are done with the algorithm. So let's explain the algorithm now. Right, so let's explain how this works. So this is the n queen algorithm, and this is the structure you pass to the computer to perform, to be able to solve the n queen problem. So it can be any n, right? Even if it's 8 by 8 chessboard to solve it. So now let's look at this. Now we have the column 0, 1, 2, 3, right? And that's what we have here, right? Now if it's safe for placing this queen, So now look at it. You can see that we have already explained all the rules here, which will have four rules: one, two, three, four. And you can see in row in column zero, which means that here we have board. We are starting this row. We are starting the row. The row starts from zero, right? So it will now be when column is zero, it will be board, row zero, column zero, right? Row zero, column zero, and row zero, column zero, right, past all the rows. So it replaced the queen here, right? So it move over to the next row, which is this. So it move recursively move over to the next row, which is row plus one. So row plus one becomes what? Row plus one becomes zero plus one, right? Zero plus one. So instead of entering column one, because it's there's a recursion, it goes return back to column zero again, right? Because there's a recursion here, right? So it has passed the route to have placed the queen. So instead of moving back to like it's going to the next row, like column two, column one, because we're in column zero, right? So because it's recursion, it goes back again because it's calling itself. So it goes back again to row zero, but this time around, the column becomes what? This time around, the row becomes one because we are adding in one, then column zero. So it means that I want to find out if row 1 column 0 is safe for placing a queen. Now if you check, we can't place the queen here, right? We can't place the queen here, so it's not actually safe. So now that is when it will now move down to column 1 to check if it's safe, right? Remember that it only satisfies this true and then this performs, right? So but based on we can place the queen here, right? So this instruction will keep on going, right? And the iteration will keep on flowing until we find a safe column, right? Until we find a safe column to place our queen. So now we'll now enter the column one now. So this is board, which is row 1, column 1. So it's row 1, column 1 safe for placing a queen. Now looking at this row, it's not actually safe, right? So it goes to board, board, row 1, column 2. So it checks row 1, column 2. So row 1, column 2 is safe for placing the queen, right? Row 1, column 2 is safe for placing the queen. So now a recursion happens again. Recursion happens again, then it will be row plus one, which becomes what? Board. That is 1 plus 1 becomes what? 2, board 2, column 0, right? Board 2, column 0. So board 2, column 0, which is row 2, 0, 1, 2, right? Row 2, column 0, this is 0, 1, 2. So it checks if it's safe for placing a queen, but based on the rules we have explained here earlier, it's not safe. So you move on to this one here, it becomes what? Board 2, column 1. So it's board 2, column 1 safe for placing a queen, which is not safe. Then you move on to the next one, which is board 2, column 2. So it's board 2, column 2 safe is not safe. So you move on to the next one here, which is board board 2, column 3. So it's board 2, column 3 safe for placing a queen, right? Now board 2 is not safe for placing the queen. It's not safe for placing the queen. What it does now, so what this algorithm does now is it changes this, it backtrack, right? You remove this and it backtrack, which is now like -1. It takes it back to the previous row, right? And then which the previous row is board 2, column 2, which went earlier, right? So this is row 2, 0, 1, 2. This is row 2, this is 0, 1, 2, right? So this is where we're trying to find out if it's actually safe, right? So it's not safe, we take it back. So we are in row 2, column 1, so, which is row 2, column 1 is not safe. So we take it back to this one, which is actually in row 1, column row 1, row 1, column 2, which is this one here, row 1, column 2. So this one here we change to 0 and to move to the next one here, right? Which is safe, which becomes what? Which is safe, which will be row 1, column 3. Move to the next one, which is board, row 1, column 3. That is how it keeps on doing the recursion, right? Just like the way we explained how the enquire works. That is, keep on doing this until you successfully place the queen in every possible dimensions, in every possible rows and column like this. You can place the queen here, right? So here we can place the queen, we can place the queen here, we can place the queen here, we can place one queen here, and we can also place one queen here. If you follow up this instruction, that is how it will work until we successfully place all the queens in their possible rows and column. Right, so that is how the algorithm works. If you have any question, feel free to ask me. I'm always here to answer you. Thank you, and God bless you.